You can hear me at the back? Very good. I have lots and lots of slides, so forgive me if I gabble a little bit, and if I'm too fast, slow me down. So this is very typical of testing mobile apps. We sit at our desk, we have a bunch of devices sitting in a corner that we might be using. Meanwhile, we're probably writing a test report. We're sitting there doing the testing of the latest version of the app, and we tried a bunch of screenshots, and I'm sure that some of you, like me, have sat there pressing little buttons, saving the screenshots, putting them somewhere, blah, blah, blah. So far, so good. We may use automation, we may use Source Labs, or one of the other people who provides a bunch of devices to do the testing. They offer some analytics that helps us. All this can help augment and improve our testing. But real testing, so real use, is very different from much of our testing. So users are using devices on the go, in chaotic environments, when they're bored stupid, when they're running down through muddy fields, and when they're grumpy. And sometimes some of us use it when we're driving. So how much of our testing reflects what real users do? So typically, our testing is a tiny, tiny subset of what's possible in terms of the actual use of our application. So we don't mirror many of the real uses of our application. How many of you got a mobile app that you are somewhat responsible for? A couple of you? Okay. So most of you. Okay, fine. So in terms of the complexity of your applications compared to the complexity of your testing, I suspect there's much more complexity in how the app's actually used by real users than the testing we tend to do in each cycle, in each iteration, in each release of the software. Our testing isn't necessarily reflective, so it doesn't have high fidelity of how the software is being used. And in terms of devices, how many of you test on more than 10 devices? More than 100 devices? 1,000? Okay, so we'll come back to that. So I've got a bunch of questions we want to think about. First is feedback on our testing. How many of you tested a mobile app for more than a year? All right, so you've probably gone through a bunch of iterations. How much do you think you've improved your testing in the last year? Is it structurally changed? Is it slightly changed? A little bit of tweak here, a little bit of automation? So for many of us, we tend to repeat what we did last time. We're often driven by regression testing and other tedium that says, well, you have to do all this as well as the new little stories we're testing. So we can think a little bit about the feedback in our testing. How much information do we capture when we're testing? If you're like me, sometimes you'll be sitting down, you'll do maybe a testing session of, say, 45 minutes, and then you try and remember, what the hell did I just do? And you remember a few bits and pieces and write them down in a log, and perhaps you'll file a couple of bugs, but you'll miss a lot of the details because they just wash by us. And how much effort does it take us to collect the information that would be useful to help us with our testing? And then we can go on to representative nature of the testing we do. Does it represent how the real users use our software? And ultimately, from a business perspective, the value of our testing. I assume that you mainly get paid? Does anyone test as a volunteer? Okay, so you all get paid for what you do. So ultimately, someone has to justify your paycheck. And if you want promotion, maybe you need to justify why you think you're worth a little bit more money this time. We've got a couple of different broad categories of feedback. We've got what I describe as analog feedback. It tends to come from humans. Sometimes we ask for the feedback. Sometimes people give it to us anyway. It tends to be variable. How many of you read the reviews of your apps in the App Store? So quite a few of you, you'll know that sometimes it says awesome misspelt or some rude word. And occasionally we get something useful from the feedback. But we know we have to cope with the vulgarities of the language. How many of you cope with apps in, say, more than 10 languages? Okay, so relatively few languages. I'm responsible for an app, which is a Wikipedia app. We have 110 languages. So we're getting feedback in Arabic, in Chinese, in many European languages, Russian, etc., etc. And although with the Android app we get Google Translate auto-translating it for us, it isn't very good, so we have to try and make sense of the feedback we're getting. Often people write feedback because they're emotional. They're happy, they're sad, they're pissed off, something went wrong, etc. And it's ultimately human-oriented feedback. Digital feedback is generated by software, whether it's the tools we're using, whether it's built into the application. It tends to be consistent, it's driven by code. Ubiquitous means that it's everywhere. If it's in the application, it's available for every time the application is used. But it lacks the emotion. We don't really know what the human's thinking when the application's being used. All we know is the application's being used. And the focus is really on the machine side of it. I'm going to talk first of all about freely available information. So this doesn't take much effort. Some of you may already be using some of these. Perhaps some of you are using all this information. The examples I'm giving you are from Android. There's similar examples available for iOS, which are really the two main platforms we're dealing with in 2018. So here we can see on the right-hand side, we've got installs, it says it's plus 13%, deinstalls, plus 9%, so we can see they're going up, and it seems like a few more people are keeping the software on their devices for a little bit longer than normal. This might be useful. We can see that, for whatever reason, Cuba seemed to really like, this is Wikipedia, by the way, so Cuba seemed to like the software, then Yemen, then the US is the third place, etc., etc. On the left-hand side, we're looking at crashes, and Android has this thing called ANRs, which is application not responding, so we can look at those. And those are all captured automatically by the operating system. So I don't have to do anything special as a developer. I just get this stuff. I can log on to the developer console, which is what I'm looking at here, and try and interpret it. And Google does quite a lot to try and help us understand the patterns. It says, by the way, we last saw this yesterday, or we first saw this 3 months ago. It seems like it's going up. It seems like it's going down. So if we pay attention to this, it may help us understand how our software is actually behaving for real users. And we can then have a think about, well, it seems strange that we've got this crash here, this null pointer exception. Did I find that in my testing? And if I didn't, was it deliberate? Did I just miss something? Perhaps I'm missing a test case that would be useful to me. Are any of you familiar with this picture? Who has an Android application? So this used to be an opt-in service. Essentially what happens is every time we upload our software, our APK file, to Google Play, it will automatically run some dumb tests. So dumb monkey tests, and essentially it starts the application, sends in a bunch of touch events for about 5 minutes. It records it as a little video, which you can watch afterwards, and it tries to determine if the application stops or crashes. So nothing intelligent, it does the same crap of these little inputs, whether it's Google Maps, or whether it's Wikipedia, or whether it's a gaming application, or whether it's PayPal. So it doesn't know or care, but it's surprising how often it finds bugs. This particular example is from 2 years ago, and we can see with 32, there's this sort of red bar. And the red bar says that devices had issues. If we look down at the bottom, we can see little sort of no entry signs going down on the left-hand side, and then we've got a bunch of ticks. I don't know if you can see, but can anyone spot what might be a pattern here? The version of the Android. So what had happened is we're using a Google library to display the layout, and although it was supposed to work, there was a bug in Android 4.4 that meant that the layout inflator, as it's called, which takes a sort of XML that describes the screen, crashed. And when it crashes, an exception. Now we should have found this ourselves, to be clear, in our testing, but we're a bunch of volunteers. Perhaps we didn't have an Android 4.4 device, or someone just took a punt and pushed out a new version of the software. But this caught it for us, and we were able to address the fault before it affected the users. It's what known as the pre-launch report. And Google are continuing to enhance this over the months and years, so it's now more comprehensive, testing on newer devices. I see at least one person here from India, so we can see it's testing in Hindi, for instance. Now Google is also testing in more languages, which again is useful for us, because we get new and interesting bugs when we're testing in different locales and languages than we would do if we were just testing in English. Another example then, reviews. So our app's doing reasonably well, this Wikipedia stuff. We're about 4.495, so just under 4.5. So we're pretty high compared to most applications. You can see we've got in the order of 10,000 ratings from people. And of those, roughly 40% of them have got words written along with the star. So we might get a 5-star but no words, or a 3-star with some words, etc. And again, on the left-hand side, Google is doing some tracking and comparing us to similar applications, whatever Google believes to be similar to Wikipedia. So we get some idea of design or resource usage or speed of the application, and that might be useful. And this is where users have said, there's a problem with the performance of the application, or it crashes on my device. So Google minds that and then gives us some sort of feedback. The Google algorithms are buggy. They get it wrong quite often, so it's worth drilling in and looking at the reviews it's highlighted, because they may be otherwise confusing to us and misleading. So, and yet, we've looked at what's freely available for us. How many of you know what this application is? It's the second screen. Well, you're all at the conference called SourceCon. This is the conference application. So, well done for anyone who downloaded it. But if we look down here, oops, how many of us are actually going to install a 3-star application? Yeah, if we look at here, this is a very typical sort of C-curve of reviews. A bunch of people give it 5 stars, a bunch of people give it 1 stars, and then we've got a collection in the middle. It tends to be the collection in the middle that are more interesting in terms of the bug reports that we've got. So how many downloads have we got of the application? It's somewhere between 100,000 and 500,000. We've got 160 reviews for at least 100,000 downloads. So anyone want to guess what percent that is of the user base that we're getting reviews from? 0.1. So it's very typical with an app that we're getting somewhere, maximum of just over 1%, often 0.1, sometimes a little bit less. So who are these users that we're dealing with? How many of you have actually written a review of an application? 1, 2, 3. So 3 of you from the population here, and yet I'm sure you've installed many applications on your devices. And you've probably trusted someone else's rating. If it says 4-star, you're likely to install it. If it says 2-star, you're not. And yet we don't bother contributing. And we're at a testing conference. So it's kind of interesting, isn't it? So if we only look at the feedback from humans, we're missing roughly somewhere between 99% and 99.9% of all the usage. This is Kindle. I just wanted to show you that even Amazon isn't immune from all this. They'd released a new version of Kindle for iOS. And we can see it's too small for you to really read, but it says perfect and keep getting better, 5 stars. How to break an app, 1 star. Awful, 1 star. App update ruined my Kindle. Blah, 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 blah. What did you do, Amazon? So quite brutal feedback here. 6 days later, guess what they did? They made a new version of the software, which is quite fast. If any of us have worked with iOS, we know it sometimes takes a few days to get approvals. Apple doesn't give any special favors to Amazon or to Google or to Microsoft that I'm aware of. So they worked quite hard to get this release out. Again, it's quite hard for you to see, but if you look in the bottom left-hand corner, on the 6th of April, so 1 day later, we had 22 reviews for the new version, compared to 222,000 reviews. But that same version, which is unchanged, a month later, was up to 565 reviews, and we can see it was actually doing better than all versions. So it seems like Amazon got this version of the software right. Might be useful to know. This is an example from an app I was working on. We had dropped from 4.4 to 4.3 in the ratings for the Android app. Any guesses what difference that made to the downloads and our revenue? Is it going to be less than 1%? Sort of 1%, 5%, 10%, 20%, 50%? 5%. We're actually closer to 10%. And what was surprising is it actually affected the existing user base as well as the new users who are coming on. And we'd found there was a bug for it. I'll come to that bug in a few minutes and explain what happened. So the reviews can help us identify tests that we may be missing out. This is a banking application from a small bank in the US. The text is a little bit hard for you to read on the screen, but we can see in the second one it says 3 stars, needs some work, does what I need it to do when I can actually sign in. If I'm not on Wi-Fi, I have to enter my password 3 to 5 times before it will let me sign in, blah, blah, blah. So if I was responsible for testing this application, I might think about doing some more testing where I'm not on Wi-Fi. Because perhaps I'm only testing in the office. Perhaps I haven't actually got out of the office and connected on the mobile networks. So we can see good feedback from users. We can improve our testing using that. This is a Google application. We'd hope that Google would be better, particularly at communications. And what we can see here on the right-hand side at the top is battery drain. So you're complaining about battery drain there. There's someone complaining about network settings, someone complaining about the two different speeds of the Wi-Fi network, 2.4 gigahertz and 5 gigahertz. So all of this might help us to think better about our testing that we're doing. Moving on then, this is where there's a little bit of work that we'll need to do to take advantage of the data, and we includes the development teams. Again, this is the Wikipedia application. So at the top in the little red box is a line of code. It's actually 3 lines of code because we've formatted it that way. And that's a log message. Developers typically put log messages when writing software. They tend to put it sporadically, and sometimes with very little rational reason for why they put log messages there. There's a log message in the code base that essentially says our application was started from something known as a file manager, which is where we've got something a bit like Explorer on the Android device, and someone's clicked on the file, which is a Wikipedia content file, and it started our application. When the software is running, we see in the gray box, we've got the message that actually shows the name and the path of the file that was loaded. Now, we've got in the order of 10,000 different Android devices using our software. If you've not had to suffer Android and where it stores files, good luck. It used to be it was always in one place, the SD card, but now it's in this thing called storage emulated 0, but it might be on an external card on, say, a Samsung device, somewhere else on a Longshine device, etc., etc. And we've had lots of bugs to do with file handling, particularly on old versions of Android. So the log can help us see these problems. And we can see later on that it's reading a file called index.html. Our content is actually stored as web content on the device in a compressed format. So we can see something is going wrong here that might be useful. One of the challenges then is, given that we've got log messages, and they tend to be of variable quality and written by different developers, perhaps we can improve the quality of the log messages we write, and we can structure it so it's easy to process the log messages from a development perspective and from a testing perspective. This example is from a company that used to be called Logmatic. They've been taken over by another company. But it's a great paper on writing better log messages. And we can see here that they've just changed the formatting very slightly to put the little equal signs, and they make the text on either side without spaces, so we can extract that with a program trivially and start to mine this and look at the testing we're doing. And if you have to justify, say, in a regulated environment, the testing we're doing, this may help us to demonstrate and prove that we've done the testing that we claim we need to do. If we look at mobile analytics then, this is where I'm doing some research work, and I've got a couple of examples from different products. This is from Google Firebase. Firebase is kind of the new cool analytics platform. It's been around for a couple of years now. And it's much, much more detailed than Google Analytics, the old product that many of you are familiar with from, say, a web perspective. And we can see that here it's got a user journey, a single user journey, and it's telling us in roughly real time the top events that users are doing in the last 30 minutes. So we get some real feedback as it's happening of users using our mobile applications. This example is from an HP product, which is now owned by a company called Micro Focus. And what we've got is essentially, it's called a sound key diagram, but it means that we've got a certain percentage of users going from here to here, but a few of them go to here and a few go to here. So there are paths going through the software, and these are all the different user journeys going across. And if we're testing, it's important that we're testing similar user journeys and making sure that we're covering similar paths that the users are doing. Conversely, we may know there's another function in our software. We added a new help page. If we see that no one's going to the help page, perhaps there's a problem here. Perhaps it's a usability problem. Perhaps the button has got the wrong label and it's confusing people. Perhaps there's a bug that means the software crashes. So this can just help us to think about the testing we're doing and potentially improve it. And all the different analytics platforms have something similar to this. This one I'll just mention briefly. Again, it's the HP product, and they have something they call Fundex. And Fundex, they're trying to infer from the analytics whether the user is happy or not. And they look at things like how slow the software, how many crashes there are, to infer the happiness of the user. So an interesting concept. Not sure how useful it is, but we might see this turning up in other analytics platforms. We were testing software. We had 45 languages, probably about users in 60 or 70 countries. We were based in London, in Soho. And we had people in the team from everywhere. So certainly from Europe, from Africa, from the States, South America. Guess which language we tested in? English. Because it's a common language in the office. And we just rolled out a new release of the software on a Friday afternoon. And we happened to look at the analytics. We're using a couple of commercial ones and our own one. And that's where our users were. That's where we had the hotspot in Paris. Any guesses the main language that users use in Paris, France? German. Something similar. I think it's another European language, but it's mainly French. So we suddenly realized that this is dull. Come on. But it took our collective brains to realize that we have to test in the languages our users use. And rather than guessing which languages to test in, we can actually use it based on data. If we look at feedback cycles of our testing then, we use our test results to try and infer how the application is doing and how our testing is doing. We use App Store feedback, and quite often other people in the business will care about this. We'll have analytics, and typically your business people will be looking at analytics and saying our growth in North America is 20%, Canada 15%, et cetera, et cetera. And some of us are paying attention to social media. So we'll be looking on Facebook, Twitter, and seeing what rude things people are saying about our software, so we can try and deal with any problems before they get out of hand. Make sense? The width of the lines is meant to represent the sort of amount of feedback we've got. Analytics is a very thick line of feedback because we're getting it from all the install base of the users. And roughly how it works is we have a bunch of mobile devices here on the left-hand side. They have some additional software library built into the application. Typically, developers write a bit more code to write additional messages. It gets sent typically over the internet to a collector. It's often a third-party company, say Google or Mixpanel, etc. And then it goes into a big database. It gets filtered. We don't see the raw data. We only see the pretty graphs typically. And then we go and log in and look at the pretty graphs. And some of them have APIs to allow us to access the data. But this is the broad process that's involved with this. Now, one of the great powers of using analytics data, compared to, I suspect, all your teams, is teams are limited by what they know and what they think to be true. So we might think that our software is being used this way, we might think we've done enough testing, etc. But once we start to look at external data, we get a much better idea of what's actually happening, and we no longer need to guess how our users are using our software. We can reduce the cost of operations. The software ranges from free to probably hundreds of thousands of pounds or dollars a year. So if you've got 10 million, 100 million users, you're probably paying someone for your analytics service, even if it's Google. And the real usage we're getting from the field can hopefully help us improve the testing and bring additional realism. If you remember before, I gave you the 1% challenge. This is the minus 1% challenge. With analytics, how many of you have knowingly enabled analytics in any app you've got installed on your device? Okay, a couple of you. So Gmail, how many of you enabled analytics on Gmail? Or Google Maps? Or Facebook? We have to actually go and look for the settings because the default is it collects data. So the rule of thumb is they all collect data on us, and somewhere in those long terms and conditions, 128 pages, Apple, you'll get down, we collect data on you. Okay, fine. And we accept that as we start the software. So that means that this whole user population, every time they use the software is sending analytics data over the internet. One of the challenges is that sometimes our users are offline, perhaps in an aeroplane that doesn't have Wi-Fi or whatever. So we may not get that data or they're behind a firewall. So sometimes it's important to understand where the 1% are that are missing from the data that we have. I am honored. I've never had so many pictures, not even my wedding had this many pictures. So this is academic research. It was a multi-year study of 2 applications in the order of 20 million users of the software. So a fairly large scale, fairly long-term assessment. And what they found using analytics libraries is the battery drain varied by 3 times for what seemed to be similar hardware. So a similar CPU spec, similar RAM in the device, but the battery usage declined a lot. Now, of course, we've got to capture this information. If the library isn't recording the battery use, we're not going to be aware of it. So I have to think a little bit about the libraries we're using and the data it collects. Kindle Fires, now Amazon updates the Kindle quite often. I think we're probably about version 9 of the devices, somewhere close to that. This is an older device. And what they noticed is that on a particular model of the Kindle Fire, that the battery was dropping much faster, about 40% faster than any of the other devices. They really learned this not from the battery drain, but from the session duration. So this was a game, and typically users were playing the game for about 20-25 minutes. On the Kindle Fire, it was about 15 minutes. And they're sort of scratching their head, why are people using our software for less on a Kindle Fire? And they tracked it down to the battery usage. And even though the user didn't know that the battery was going down, they didn't have a counter saying it's used 17% battery, somehow, subconsciously, they were aware that something was going wrong, and therefore, they reduced the session length of playing the game. So the developers put some custom code in and said, essentially, if a Kindle Fire, just tweak the brightness down a little bit. And when they did that and made the release, the usage came up again on the Kindle Fire. So a very good indication of correlation at least, and possibly causation. They looked at things that we'd probably assume are fairly obvious, so higher network latencies for network-based applications reduces the use, and users prefer Wi-Fi. What may be unusual is that tablets is 2 times the usage of the software, and also on the older Android devices, some had keyboards that pulled out, and we found we had much higher usage on those devices. So if we look at testing based on analytics data then, I've got 2 broad groups. What I call testing based on information, so things like popularity and volumes. Locales, I talked a little bit about languages, and locales goes into a bit more detail. So for instance, if we have French as a language, French is spoken across West Africa, it's spoken in France, of course, it's spoken in parts of Switzerland. So each of those will be different locales. That's why I'm differentiating between 2 of them. And similarly with Spanish, we'll have Spanish that's spoken in Spain, and Spanish that's spoken in Chile, Spanish that's spoken in America, etc. So we'll have a number of locales that represent that. We'll look at things like user flows and crashes. And the aim here is to quickly be able to hone in on a problem or something that's happening in real life with real users and be able to reproduce it in our environment. And then we can look at things like the logs. Something weird's happening out in the real world. Let me bring it into the lab, do some testing, reproduce it, and hopefully address whatever the concerns are. We also get insights. Now, the insights could be that we noticed that the Samsung S7 was the most popular device last release, but it's dropped to the 10th in this release. Now, something must have changed. It wouldn't have been obvious to us if we weren't paying attention to it, so we need to find out what the heck's going on with that device. Again, there may be a bug that we're not spotting in the code, but something to do with usability, for instance. So it's important to look from that perspective, and here we're trying to maximize our insights and our agility to respond. Logically, I see a mobile application as 3 layers. We've got the user interface, the GUI. We've got the application logic, which makes your code special. And then we've got the operating system. The mobile analytics focuses very well on the application logic. So what makes Gmail special compared to anything else, for instance? What makes Facebook Messenger special compared to any other application? We get a little bit of information about the operating system, a little bit about information about the device, not much about what the user sees. There's something called heat maps that can help us in this area. On the right-hand side, we've got screenshots from a company called Appsy. Appsy, I think, is one of the better products in this area. So on the left, in that ugly, glorious all caps, that's the terms of service. So the user has to click through the terms of service on the left-hand side in order to get to use the real software. The heat maps, we can see that the sort of purpley color is where users aren't clicking. We can see green is where people are clicking a little bit, and red is where people are clicking a lot. So if you notice carefully, we've got a bunch of people clicking here, which is on the agree and continue, which is where most of us would hit, wouldn't we, to get rid of this stupid message. We've also got a bunch of people pressing here, and there's a little tick box here tucked away. It's hard to see. So a lot of the users were missing that tick box, and roughly, I think it was 27% of users stopped at this point. That's quite a lot. Over 1 in 4 users stopped using the software and never got any further. So that little downloads, these are the users who uninstalled your software. And what they noticed is that people were missing the tick box. They were also pressing the button without the tick box. And if you press the button without the tick box was essentially need to be ticked for the button to be active. So when they knew this, they changed the design of the software to do 2 things. One is, if you see where there's a tick box and I agree to the terms of service in sort of grey colour, they made the whole of that an active area. So if a user pressed anywhere on that, it ticked the little box. And also where it says agree and continue, if people press that first, it had a little pop-up box saying, please can you agree to the terms, and tick the little box. So it helped the users who couldn't see the box to at least know it existed. And when they made those two changes, then users continued to use the application. So it improved the usage. I've mentioned logging, mobile analytics, and heat maps. So these are sort of my view of the sweet spots. Logging, you typically need access to the device. While you can write software that gets logs off remote people's devices, there's a single log for all applications. And I don't know about you, but would you really want some software pulling logs for everything else you're using on the device? No, I don't want that either. So it's typically devices that we have control of, but it includes the developers' devices, internal testers, etc. Mobile analytics, I would say we can put in all applications, and we can use it to look at our testing and also how the users are using the software. And heat maps, if it's things like non-sensitive data, so maps, it's maps and people navigating maps, or we've got a trusted relationship with the users, so perhaps they've signed to be a trusted tester or something like that, then heat maps can be really useful. And typically you'll get a video, it'll actually show how users got to a point, so we can see, for instance, the user has a crash on their device, we can go backwards and watch a video and see what the user was doing in case there was a correlation. How many devices do we test on? At the top, we've got 2 device matrices from a company called OpenSignal. They essentially provide information about the signal quality in different countries in the world. And this graph was done in 2015, it was published, and it's 25,000 devices, Android devices, use their software. On the left-hand side, it's grouped as a patchwork based on popularity. They've resorted on the right-hand side by manufacturer. At the time, Samsung was roughly 40% of all the devices used. So in their case, if they weren't testing on a Samsung device, more fool them. But if they wanted to work out which was the next device to use, would they pick a Longshine device, a Sony device, or a Motorola device, or whatever this one called an Oppo? They're probably not going to be getting Oppo devices to do their testing on, but they would want to test on representative manufacturers. At the bottom, we've got 2 graphs of different years or different eras from iOS support matrix. I personally prefer the one on the left-hand side. The one on the right-hand side was done in the winter about 3 months ago. Sadly, their website is down at the moment, so this was a cached image from Google. It's well worth looking at, though. It looks at the operating system versions and the capabilities of the devices. This is academic work. I've got 2 minutes left, so I'll be quick. But it's worth looking at things like which device do I test on based on where users complain. So if users complain and they're using a Sony Ericsson device, perhaps I'd want to make sure I test on that device. And this is an approach looking at game software, both free and paid software. So given we've got all this, it's necessary but not enough. This is an example from another academic paper. And what we've got here are key presses. And with each key press, there's a network request going out from the device. Now my question to you is this a bug? Every time the user presses a key on the screen, there's a network request. Bug? Yes? Bug? No? So let's imagine it's Google search, and it's doing the autocomplete. So each time I type a letter in, it refines the search results. That wouldn't be a bug for Google autocomplete, for the searchers, probably. But it might be for another application. So we don't know without having context. Always be careful of the automation bias. This was a paper written about pilots and using automation to give them guidance. I haven't got much time to go through this, but do read the paper. It's only about 6 pages long. It's written by a chap called Cummings. And essentially, he noticed that humans over-trust automated answers. So the more we use automation, the more we look at green charts and all the rest of it, and test results, the more we're at risk. These are the topics I couldn't cover in 35 minutes. So the slides will be available. You're welcome to ask me, and I've written a book on some of these topics. So with that, I'll say thank you. You have my email address, Julian Harty, and I think I've got a tiny amount of time for questions. Thank you.